As Nancy said, my name's Milena, and all three of us are master's candidates in urban planning here and work for the U.S. Army, and we're all graduating in May. If anyone has jobs that are open, happy to provide resumes. So we're here today to talk about our research on water use availability and sustainability for a number of U.S. Army installations and their surrounding regions. The study actually is sort of 13 separate assessments for regions containing U.S. Army installations, looking at water supply and demand for both installation and region over the long term. While the methodology that we're going to be talked about has been developed for regions with Army installations, it's really applicable to any region, regardless of the existence of an Army installation. And the tool that we've developed specific to Army installations, we think has applicability for any large institution. It would have to be adapted, but a university, for instance, that was interested in projecting its water demand might be interested in this tool. And at the end, we're going to talk a little about some of the challenges in applying this methodology to different regions, as every region's water situation is. However, before we jump into the methodology, I'm going to give you a little background on the study, where it's coming from. So why is the Army interested in water sustainability? Well, on a general level, the Army is worried about issues of water scarcity. I'm sure this audience knows water scarcity issues, while varying, have generally been increasing in both extent and duration. So the Army is worried both about the possibility of increasing costs as water scarcity issues increase, and on the possibility in some places of compromising the Army's mission. More specifically, there are three main issues that drive the Army's interest in water availability. Number one are Army transformations. Army transformations are sort of like when a company restructures. Army units can be shuffled, various functions get moved from one installation to another. So as this increases population on an installation, in some cases significantly, it's important to ensure that there's water availability for those new people over the long term. Additionally, some installations have already experienced water conflicts with neighboring communities when water supplies get compromised. So this has happened for West Point and Presidio of Monterey. And having an awareness of water availability at a regional level can help the Army to plan to avoid running into this kind of issue. Finally, there are a number of requirements that for installations to deal with water conservation and sustainability issues. There's an executive order that mandates federal agency water use reductions by 2% a year by 2020. So the DoD passes this directly on to Army installations. Additionally, Army installations are required to address water sustainability in their installation sustainability plans. So now I have a couple of slides illustrating water scarcity generally. I imagine this is something that this audience is pretty familiar with, so I'm going to go through them quickly, but I do want to draw your attention to a couple of things. This map up here is illustrating precipitation trends, comparing recent trends to long-term averages. And you can see that in the southeast and the southwest, areas where there are a very great number of Army installations, precipitation has been decreasing, or trends are decreasing at least. And these are also places where population has been growing greatly, at least until the recent housing crisis. So that's an issue to be concerned about. Likewise, this is a map looking at drought trends, and you can see again the clusters of brown indicating increasing drought in the southeast and to a lesser extent in the southwest. And of course, climate change is an issue which greatly exacerbates water scarcity. This particular image looks at predicted change in median runoff from precipitation over, according to 24 different climate models. The colors indicate the change in predicted runoff. The numbers on top are the percentage of models that agreed with the change in direction. So this is generally showing that water runoff in the Southwest is expected to decrease due to climate change. And of course, this is just one of many water-related issues that climate change is likely to impact. And this is my last general slide. I kept this in here because if you see, this slide is from the U.S. Global Change Program, and it highlights areas that have the potential for future water conflict. And you can see El Paso is highlighted as an area with a substantial conflict potential. And I mention this because we're going to illustrate the methodology using Fort Bliss, which is located in the El Paso area. All right, so some further background. The sponsor for this project is the Army Environmental Policy Institute. And they originally became interested in work we've done represented in the map up here. This is a national screening for watershed health. What it does is it looks at nationally available indicators for watershed health, aggregates those indicators, and comes up with a general score of vulnerability to water problems on a watershed level. Now, this is... Mm-hmm. Yes, Lake Michigan, the boundaries are watersheds. And so Lake Michigan is its own watershed, and the indicators are all available on a national level. So in some cases, we might have looked at something going on a state level. As much as possibly, we looked at what was going on in the watershed. So even though this is a lake, it's still a watershed, and it still is susceptible to water quality issues, for instance. So it has a score. What I was about to say is that these scores are, of course, looking at a handful. There are a large number of indicators, but in comparison to the data out there, it's really a handful of information. And so further study is required to really ascertain what's going on in a specific watershed. And in the case of the Army, whether watersheds with Army installations really are at risk for having water problems or not. So the studies that we've been doing and that we're going to talk about today is a study our follow-ups rather, on this national screening, trying to go further into what's going on at a regional and local level for regions that have Army installations. And these are the water indicators that were used in that map you just saw. So for these particular assessments, our lab has used a water balanced methodology to look at the availability of water in regions over the long term and try to predict whether there will be scarcity or not. Water balance is sort of like balancing a checkbook, except that instead of looking at money, you're looking at water. So the water that comes into or out of a system over a period of time in a region. The period of time that we're looking at for all of our installations is 1 year. But the region of study itself, the spatial region, varies depending on what's going on in a place. So for regions that rely on surface water and installations that rely on surface water, we normally use watershed boundaries to define our region. Now, although these maps sort of stop at the U.S. border, water does not really stop at political boundaries. So this means that our regions often go over state and, in the case of Fort Bliss, international boundaries, and we have to take into account multiple regulatory schema that affect how water is allocated in different states or in different countries. Additionally, there's a upstream area to almost all of our regions. So for Fort Bliss and El Paso, the Rio Grande is fed by snowmelt from mountains in Colorado to some extent. Now, we're not including Colorado in our region, but I just wanted to point out that in all our regions, there are extra regional impacts to water supply and demand. Okay. And for groundwater, for regions relying on groundwater, we use aquifers for the most part to define our regional boundaries. Now, although this map makes it look like we know where all these aquifers end and begin, that's not really the case. The boundaries of aquifers are often fuzzy or simply not mapped, even if they aren't fuzzy yet. So groundwater systems present some real challenges in applying this methodology to be able to create the water balance when we don't know the extent of an aquifer or how it's connected to other aquifers. And once we figured out what our region of study will be, we spend some time researching the region and trying to get a handle of all the different factors that play into water supply and demand in the area. On a national level, we look at USGS reports and Bureau of Reclamation reports. Both these bodies deal with water issues in different parts of the country. USGS traditionally in the east and Bureau of Reclamation traditionally in the west. And the USGS also has a data set of county-level water use that we use extensively to predict regional demand for water into the future, to base our regional predictions off of. We also collect a variety of geospatial data sets for mapping purposes and to help us understand spatially what's going on with water resources. At the state and local level, we look at water laws, plans, and of course population growth expected for an area, as this has implications for future water use. And on the Army installation side of things, we ask installations for data about historic water demand, if possible metered data. However, for many Army installations, that's not possible. We also ask for real property data, so the buildings and facilities that use water, we use the real property data as a basis for our water demand projections. And also anticipated population growth and any sustainability plans so that we know about water conservation methods that Army installations are taking. Now I'm going to hand things over to Ryan, who will begin to talk about Fort Bliss in detail.
So zeroing in now on excuse me, on the local, using Fort Bliss as an example, we just have a few descriptors of the area that are non-water based to give you an idea. Bliss is a critical asset in the region for the Army. In the area, this is a very water scarce region. The Chihuahua Desert in the area receives only 8.8 inches of rainfall per year. So this is why Bliss may have issues with water availability and why they want to look at it. It hosts air defense artillery training and the Sergeant's Major Academy. There are about 15,000 soldiers and 7,000 civilians, although as Melena mentioned, this is changing over time as the Army plans its population through the restructuring it does, and about 1.1 million acres. Different factors in the Fort Bliss region can cause water issues. This is also the same region as El Paso, which is the third fastest growing metropolitan area in the United States. And Juarez, Mexico is also immediately adjacent to El Paso, basically adjoining it. And that's also a very quickly growing region. There's a water reuse goal of 15% by 2012, so they are doing things to help with these issues and to think ahead about them. So this tries to play into the efforts they already are making. Also, we'll be getting into some of the water sources in a second. As a primer, there are two aquifers here that we talk about. One is the Hueco-Bolson aquifer, and I may be pronouncing that wrong, and one is the Mesilla-Bolson. Both are aquifers. The major one that they get water from is the Hueco, but the Hueco has about 6 times as much brackish water as fresh water, which is saline water. So not all water in the aquifer is actually recoverable for drinking. And to use that more, the base has installed a desalination plant, which is fairly large, which I'll give a little more detail about in a few minutes. So just to define the region really briefly, El Paso is this metro region here, and Juarez is, you can see it blends right in, and this is the Rio Grande. Yeah, it's a little too small to see. And it also is the border between Texas and Mexico, and this is Fort Bliss coming down and blending in with El Paso at this juncture. So you can see why it's important to look at the spatial aspects of the problem when they're this close and they share the same regional qualities. Getting into the way the tool works that was developed, there are 3 spreadsheets. One portion covers regional water supply. One covers regional water demand and use, which predominantly uses the USGS data set that Melina mentioned that gives water withdrawals for the nation. And installation water use predominantly employs data that we get from the installation. So if this was tailored to another use, like a university setting, they may have a system they keep track of real property data with and how much water is used there. So I'm first going to talk about the regional water supply portion of this, and then I'll pass it off to Laura to discuss the demand. Okay, so this just gives an overview of the region, again, just in a more illustrative format. So here again is El Paso, represented as a point in Juarez right next door, and there are a number of dams represented by these hash marks down. And the whole thing is within the Rio Grande project area, which is controlled by the U.S. Bureau of Reclamation. So all the water in the Rio Grande is apportioned out, which means someone has the right to the water. There isn't an ounce of it that isn't promised to somebody. And that changes depending on the availability of water at a given time. And at different points, the U.S. Bureau of Reclamation determines how much goes out. This Caballo Dam is a major point where they will divert water to other users, and the amount let out there controls how much eventually gets down to El Paso. And you can also see the intersecting different irrigation districts that also control water supply here, and they'll deal with groundwater. And here are our 2 major aquifers we talked about. This is the big one, the Hueco. In extent, they look similar, but the region gets much more water from the Hueco. This slide is just to give a bit of an idea about the different treaties that govern the use of water in this area. And I won't go into it too much. The legality of water, as many of you probably know, is a study in and of itself. But it just gives you a sense of how this has developed over time. The Rio Grande began to be promised out at the beginning of the century, and since then there are various overlapping doctrines that control its use now. And that's not to mention the groundwater. And I'll go into that a little more later on, some of the differences in laws between the regions we cover. This shows a little more technical detail about the 2 aquifer water sources then. And you can see some of the spatial data Melina mentioned we collect. So these are aquifer shape files. We use ArcGIS. And the 2 callouts are 2 wells to illustrate the different levels of water. So over here, this points to the Mesilla-Bolson. You can see, not in too much detail, but it has a slightly declining but overall somewhat steady fluctuation of its water level. The scale there is 0 to 60 feet below surface level. And then the Hueco-Bolson to the east has this declining curve. So that's the well level observed at that below surface level. That's the year 1952 through 2007. So this is why they monitor this, and this is USGS data. And this is a reason that they know they need to manage water better and have done so, but continue to try to think of ways to do this in a growing region. Just a little bit more about the Rio Grande. The main point is essentially flow in the river is variable, but different amounts are available at different points. This is the release at the dam, this white bar, and then this is the amount in sort of dark gray that's actually present at El Paso. But El Paso Water Utilities, who provides the Rio Grande water in the area, actually only has rights to 50 million gallons per day of that water. So even of that flow, they don't get all of that. This is only part of their water scenario. So all these factors go together and blend into their overall water supply. So we've talked a little about some of these different things, and I'll just try to delve now into how the spreadsheet works briefly. It's difficult to figure out how to represent this in a slideshow because it has a lot of figures in it and a lot of different factors, but I can go through the overall framework. Right here, each section represents the different water supplies. So at the top, we've got the Rio Grande. Then this is the Hueco-Bolson Aquifer, this area in the middle, and then the Mesilla. And the most space is dedicated to the Hueco because it's their biggest water supply. So this accounts for release from the Caballo Dam, so the amount that's going down, and then losses to precipitation and evaporation, and also riverbed losses. As it goes through El Paso, the Rio Grande, which used to be a gaining stream, which means it would gain water from the water table because of pumping, over the years became a losing stream. So it actually loses water as it goes through and can in some years run dry after it gets past El Paso. So that's a big factor. Then in the Hueco-Bolson, similarly, you have recoverability of water, so basically the amount of water that's there. But as I mentioned, some's fresh and some water is brackish or saline, so that's not recoverable unless they desalinate. And it's unclear as to how much is actually saline and how much is fresh. So that's an area of ongoing engineering study. And with different scenarios, there can be changes in freshwater storage. So the aquifer is recharged from the Rio Grande, from precipitation. It's recharged from other portions of the aquifers and portions of adjacent aquifers that feed into it. And then desalination discharge that goes to Mexico. So if Mexico pumps in the bottom, the underground flow brings water away from the Texas portion. And freshwater withdrawal for water supply represent withdrawals from that supply. And there can be a change in storage. So different pumping actions can cause saline water to move around, and it can cause more fresh or saline water to move in than from other parts of the aquifer. So as you can see, this is all really complex science, and this study doesn't try to do detailed engineering work on this, but it looks at other detailed expert studies to try to feed that into an overall picture of what people can expect and help them make decisions. And this just represents a part of the spreadsheet that lets us construct scenarios. So this is just one example. Scenario 1, we're assuming some amount of climate change. So this is predicted, for example, to cause a change in Caballo release 20% less. So if it can cause a change in precipitation, which can cause them to be able to release less water to be available later on. And then there are also other factors such as artificial recharge. One program that El Paso Water Utilities, the utility in the area, has been using and may use more is the practice of taking some of their desalinated water from the plant and actually recharging the aquifer directly with it, because then it's not subject to evaporation. So the model can then incorporate those changes if users want to show what that would look like. So this is that scenario that I got into a little bit. And I'm just going to go through the 5 scenarios briefly and then turn it over to the demand side. So global circulation models predict about a 12% decrease in precipitation for the region and an increase in temperature. So this scenario tries to represent it in that little portion of the spreadsheet you saw by a 20% decrease in river flows and a 35% decrease in natural recharge. So you can just see those represented as the arrows, and that's going to remain constant. And we have some results up here for what the model then predicts, given those supply factors, the output of water would be. And they build upon each other. So then this scenario also adds in increased pumping in Juarez. juggling. Okay, so ORES says they'll maintain the current pumping levels, but they may increase it. There have been conflicts in the past, so that could alter the volume of water transferred into the Texas portion, and also the volume of water from river recharge and the volume of water transferred to Mexico. So this should produce an overall decrease. It's difficult to predict in aquifers, and it's a really complicated area of science because one action can cause ripple effects throughout, and the shape and structure of the aquifer isn't fully understood. But we think that could lead to an overall decrease. And then if the local people working on this have different research that comes out, this can then be altered to incorporate those changes. Third scenario is induced recharge. So this is building on that last one, but if they desalinate more water at El Paso, then they can recharge it back into the aquifer and take it out of being subject to evaporation, although this can have other side effects. And then a full capacity desalination. So it just increases the amount of water they're desalinating, which increases the availability. So these were then shown to the bases, and we got feedback and had a dialogue about it. And this worst case scenario is essentially just changing these two factors. If climate change effects are worse, this tracks to the, I guess we'll call it the worst case scenario global circulation model that's out there for decrease in precipitation and so on. And then I'll turn it over to Laura for the demand side. Okay. Where's that clicky?
Good afternoon. Hi. My name is Laura Kirby, and I'll be talking about the regional water demand model, the basics of it. I'm not going to be showing any sexy spreadsheets on it, but no offense. And then I'll discuss some of the other things besides USGS data that go into account when we don't have historical data that it pertains to. And then I'll discuss the installation water use demand model that we use to apply to each installation. And then further on, we'll talk about how each regional challenges have their own context that need to be understood, and how we've and some of the information that goes with that. Okay, like I said, USGS data is the main historical data that we use, but the other water demand sources that we want to take into account is the population growth with the historical U.S. Census Bureau data, but with the local and state, we usually try to go with their population forecasts. Along with the Army transformation, we have to take into account the growth with the Army base itself. Usually the base, if we expect it to grow, the surrounding population is going to respond to that, and you're going to expect businesses and other population to grow around the base itself. For this particular region, overdevelopment, we refer to kind of the type of development that's been going on in the southwestern part of the United States. It's pretty much low density and pretty much large square footage of homes. So we expect that there's going to be a larger area that's going to be covered and larger infrastructure that's going to have to go with it. On top of that, we've got aging infrastructure. As you know, there's the information about old water pipes and own private practices. The same thing is going on with the Army bases. Many of the buildings at the Army bases are original buildings from World War II, and most of them date back to the Vietnam era. So they've got a lot of old piping and a lot of old systems in there, and they're just now getting around to changing them. Another point of interest is increased energy use, both with climate change and renewable alternative sources. Climate change itself, we expect with the temperature to go up, it's just going to take more water and more energy to keep things cool as they were before, as straightforward as that, such as, you know, with with nuclear energy plants and for actually planting crops, especially in arid areas as Arizona. On top of that, for the renewable energy sources, we have to take into account these renewable alternative energy sources also take or may take a lot of water in their processes. For example, Davis Monthan Air Force Base, I believe it's in Arizona too. The idea for solar panels is a great idea for alternative energy, but for optimum use for the solar panels, you need a lot of water to clean them and to maintain them, so for them to actually be effective. The map up there to the bottom right is referring to ethanol plants, ethanol processing plants that are being located in potentially already water-stressed areas. So, as we all know, there's a change in the use of corn there's a huge shift to using corn for biofuel. Well, you have to take into account that the water it takes to actually grow the corn, and then the energy and the water it takes to actually change the corn into ethanol. So you can expect if something like this is to be built in the area, that's going to be an additional water demand. And so we try to take those into account on top of the USGS data for forecasting. To give you a kind of a broader review what the Army transformation is looking like on a national level. It's affecting over 304 installations and locations. It's impacting over 380,000 soldiers. It's the largest Army transformation and organizational change since World War II. It's restationing approximately a third of the Army by 2011. And on top of that, the Army is expecting to grow by more than 74,000 troops. Overall, they expect to have new construction projects, over 740 new construction projects at a cost of over $66 billion. And they're expecting to build at least 69,000 barracks and over 4,100 family housing units throughout all the different Army installations. For Fort Bliss itself, as you can see, as it's circled in red, the number there, the change was initially at 13,742, growing up to approximately 40,000, but that has actually gotten higher as it referred to the 300% growth. Hello. Let's try the next one. There we go. Okay, so for actual regional demand, we took into account Juarez and El Paso County for these and for the population growth. For 2050, the area is supposed to grow from 1.9 million to almost 4.8 million. Majority of that growth is expected on the Juarez side. But for the El Paso County, the number of households, based on the low density that's expected to be zoned in the region, the number of households is also supposed to match the actual population growth in El Paso. So we can assume that a lot of land is going to be covered with housing. Based on that approximation, we're also assuming, since the housing is going to take over into the agricultural areas, agricultural use will actually decrease also. So for overall water use, majority of the increase in water use is going to be on the Juarez side again, whereas El Paso should maintain only approximately about a 1% increase. And that's taking into account the reduce in agricultural use and the new water programs they're starting to implement. Okay, so specific to Fort Bliss, I'll discuss the model, and I do bring in some sexy spreadsheets on this one. Overall, the water demand model provides a rough estimate of future water consumption at the installation level. It's based on the current trends, the future construction that the installation expects, the future stationing or the population growth, you can call it, the irrigation requirements at that installation or university, you can call it. The model is specific, and it provides a baseline that can be calibrated to that specific location. And it provides guidance in disaggregating the data at the installation. As you can see, it goes down to industrial maintenance, housing, medical administration, operational buildings, training schools, and storage. So it breaks it down to a pretty good, to that level. Now, this spreadsheet, let me go bring this in. This spreadsheet shows kind of where we have two main spreadsheets. This is where we input all the data that we get from the base itself. These bottom lines are factors that, say for example, we have a base that's still in the process of constructing and expanding. We have only the latest property data from today, but we expect it to increase another 50%. Then we can reflect that in factors later on by saying, okay, 1.5 if it's going to grow 50%. And the bottom lines, we still have some base input data here for actual consumption after understanding the actual per unit consumption. And then the bottom group here, this is where the macros actually comes into play. After we put in the list of the real property data, the macros cranks out numbers based off standards provided by the American Water Works Association. From this input, this spreadsheet's created, reflecting the previous data input and then reflecting the factors that we've put it in and changing them to actual million gallons per day consumption. After all this is added up, it creates an overall consumption of million gallons per day for Fort Bliss. This figure shows how the water consumption would grow with the BRAC as they gain population. The dark straight line is goes up to about 9.5 million gallons per day, and it stays straight because the Army only plans out 5 years in advance. 5 years ahead. So after that 5-year point, they can only assume that it's going to be maintained the same. The dashed line, unfortunately, only reflects to 2015 for its change. It's supposed to actually reflect out to 2020. It reflects the 2% reduction rate that the Army is relegated to enforce according to the executive order passed down from the White House. So the dashed line should actually be a little bit lower in maintaining a straight line at 2020. Okay. Overall expectations and recommendations we have for Fort Bliss. Even though Fort Bliss is a small percent of the whole water usage, and it still contributes to the increased water stress, and it needs to recognize that. Some bases and some installations just don't recognize that, so that's the first step. The other recommendation is local water authority and Fort Bliss should really pursue the artificial recharge and expand it if they can. And they both need to understand the future water supply in the region, and Fort Bliss itself may require, or probably will require, increased energy to obtain new water sources if they have to go further out to obtain them. To the further extent possible, Fort Bliss and the region should integrate conservation practices as in the scenarios, demonstrated in the scenarios. And the legislation and future legislation will have to probably contend, depending on the worst case scenario, how it plays out, that there may be more demand than available supply. The next group of slides, we're going to discuss a little bit of other regions as in comparison to Fort Bliss and how their contextual water issues play out. Specifically, Fort Irwin, which is very similar to Fort Bliss, it's a very arid region. It only gets approximately 4.0 inches of rain per year. It's has even more severe water issues because it does not get replenished. Only replenishment it really gets is from artificial replenishment through wastewater percolation. All the water is strictly groundwater source located within the fort boundaries. So it doesn't have to compete with other populations, but it can't go outside the boundaries for new water because of the legal restrictions. Because of the current water use and the lack of replenishment, they actually can see general timelines that they're going to be running out of water. And so here is probably the most severe case of strategic impact to training. And these next two slides, Ryan will discuss.
So in each place, there's a different legal framework, which Laura just started to mention for Fort Irwin. Another base that was studied in the pilot study was Fort Bragg, which is in North Carolina. So I'll go through a couple of North Carolina regulations. They have many different ones, but the ones that deal with water availability are the drought-focused ones. There are a variety of accounts in each water supply in North Carolina. So within a reservoir, there will be a water quality account that's necessary for retaining water quality. There will be a supply account, and there's a base account, which might be for environmental purposes, sustaining an endangered species, for instance, and all these regulations intertwine. They can do water transfers in an emergency, so taking water from one place using even emergency pipelines they construct for just that purpose in a drought, but obviously this isn't a great situation. And withdrawals from these sources are regulated as a percentage of average flows in the water source. So in a stream, sort of like in the Rio Grande, a different user will get a certain amount, but it's not on an actual water right basis. The framework is riparian water law. This is the way most of the eastern U.S. works, as some of you might be familiar with. The main legal basis you hear a lot here is a reasonable use. So if one's property abuts a water body, that property owner can make reasonable use of the water within that water body as long as it doesn't impact surrounding neighbors. So there's the reasonable part, and then courts have adjudicated what is actually reasonable over time. The waters in streams are considered to be the state's water, which is why they can regulate it in the way that they do. And then groundwater withdrawals in these types of states require permits. So in contrast to that, there are some similarities, but a lot more contrast. Texas water law uses a rule of capture, which comes from British common law. If there are any other urban planners in the room, we talk about a similar thing when we talk about the difference between nuisance law and which was sort of although it's still there, was sort of the predecessor of modern zoning, in which a use on your property was prohibited if it hurt the neighboring person, but only within a really direct framework. It couldn't really accommodate sort of overlapping intentions and heavy industry, so zoning came about. The water situation in Texas, although it's been modified, is similar to that nuisance law in that if you own the land above an aquifer or above groundwater, you can pump that water. And there are really, although there are a few provisions, there are very few statewide strictures on what that looks like. So if you're actually maliciously intending to harm the neighboring property owner by depleting the water, that's restricted. But if you do deplete it and it happens to deplete his water also, that's not necessarily a problem under the state's water framework. You can't just pump it to waste it, to pour it out. But very few things are actually determined to be waste. So within that, because Texas has recognized it's led to problems, but they still are very for these kinds of property rights, they require regional water planning. So working at a place like Fort Bliss, there's a regional planning framework. So in any region, including Fort Hood, which we're also studying now, you can go to that region's water planning body and get a giant 60 to 600-page plan, depending where you are, describing the entire water situation, and then those regions can place strictures on it. But that varies from region to region. So while these things are problems everywhere, different places handle them differently. And I was going to talk a little about the difference in surface water frameworks, but essentially, different places in the West, we talked about different water rights on the Rio Grande. In the West, they usually follow a first in right, first in time rule. So that means that the water rights that came first, the people who acquired the right to the water in, say, 1953, in time of drought, would have a right to use that water before someone who acquired the water right in 1964. And they will roll back those rights in times of drought progressively. So these are all just examples of things that overlap and determine how we do this kind of thinking.
Okay, I'm coming back to explain this last slide because the majority of my research has been on overseas installations. I'll specifically talk about Germany and Germany and Italy. They're obviously part of the EU, and so the EU is trying to do this standardization of water structure with huge reverberations that actually go international borders and everything. However, as each country has their, as a sovereign country, they have their own internal regulations on how they're going to keep track of water, and that's a major challenge if you're going to try to compare them and use an installation specific model, but it's still applicable. The challenge for data standardization within and between countries is probably the largest one for the EU if you're using EU data. However, for Germany, for example, they're typical Germans. They're highly organized, and they provide pretty much a really well-rounded state-sponsored sources to find water data. Italy, typical Italy, not so much. So majority of the water data is not at the national level. It's at the regional level. No offense if anyone's Italian. It's more at the regional level. So if you're going to find data on the regional, you almost have to go to a university which may or may not have done a study on the region that you're of interest. So it's a little bit harder for Italy. And the other location is Korea, but I'm not going to get into that one yet. But as of right now, those were the main kind of the spectrum of all the different installations that we're looking at. But all of them, we've been able to apply these methodologies and still been able to do some forecasting. But overall, we just want to make sure you understand that, and I'm sure you do, water behaves similarly everywhere according to hydraulic cycle. However, the situation is different in every region, but it's very imperative to understand the unique context for every situation. And as long as you can do that, you can apply this methodology, we believe. That's it. If you have any questions, feel free to ask. Thank you very much.
Noted that there's regional water planning in Texas. Is all the data that you use for the Fort Bliss study consistent with the data used in that region in Texas?
With the regional water? So the question is whether the data we use for this study from the national level is consistent with the regional water data. that they produce. For Fort Bliss, it incorporates a little of both. So, for instance, some of the population numbers come more locally because they produce actual forecasts at the regional level as part of that water planning also. So the projection of population comes from the region, and that was assumed to be somewhat more accurate because it was updated more often than the census figures, and it's more local. So they have a feedback process where they can figure out if they actually have their assumptions correct, and they can redo them. But then the others come from the national level. I can speak more. I would have to look into that more. I can say at Fort Hood, we are checking, which is the other one we're studying now in Texas, we're checking them against each other. So there's the demand at the census, or the USGS level, rather. And then we've projected that out, and we're graphing that just for visual comparison and comparing it to that at the regional level, just to see if there's a place, say in 2025, where they diverge, that there may be a factor we're not incorporating. And we'll probably just average, sort of take the middle road between the two. Is that?
I was wondering in particular, you said that the Army only projects 5 years ahead, and therefore it's flat after that. Mm-hmm. So in providing input to that regional water plan in Texas, does the Army installation still only project 5 years and then flat? Because the Texas water plan goes out for 50 years. So,
to tell you the truth, I'm not sure.
This study kind of takes that place, I would say, because they're limited to 5 years. Sorry, they're limited to 5 years because they have such a high turnover at every base. And this BRAC kind of came out. This was decided in early 2000s, and the BRAC came out, and so everything just changed. So, as you can understand, the 2000-2005 plan, national plan, changed to the 2000-2011 BRAC. So they can only plan out to the 5 years. At the Army side, I would say they probably don't take into account the consumption. This study hopefully does.
I can say something to that. I think when you said plan out 5 years, I think you're talking specifically about stationing decisions. And you saw that slide that showed the picture of Senator K. Bailey Hutchison in Texas. Well, part of the planning for the plus-up for tripling the forces that are stationed at Bliss involved environmental impact studies and trying to identify if there were any resource issues. And water was one issue of concern. And that is actually what prompted the construction of that desalination plant. They mentioned, did Brian mention, it's actually on Fort Bliss property.
Oh, I didn't get it.
What they do when they construct something like that, they actually move the fence line. So it does not belong to Fort Bliss. It was one of the largest public-private ventures up to that point. It's about a $67 million project. And that is what enabled them to increase the stationing at Bliss. So I don't think the Army is at least going to say publicly any stationing decisions beyond what the current Grow the Army, BRAC, brigade-based organization are. So in terms of population on the base, we can't say.
Well, two questions along those same lines. What kind of costs are you, or comparison with the desalination plants? How much water are they able to put out? At what cost compared to the existing groundwater?
The question was in regards to the cost for the desalination, how the cost would be affected by the desalination plant, and what was the potential output from the desalination plant, correct?
For that one, I have a couple figures written down that are the actual amounts they'd expect to put back in. So if you'll let me, I could look them up and talk to you a little after. As far as the monetary costs it depends on the energy cost, and it is. I'll have to be really general, but I could certainly look into it if you're really interested in a comparison. Maybe Elizabeth knows.
The plant was constructed with a capacity of 27.5 million gallons per day. It's currently operating at 3.5 million gallons per day because of the cost issue. It's the second most costly source of water to include importing into the region. The costliest being building huge retention basins. If you can imagine, they would consider that at 10 inches of rain or so a year. The cost is high, and they do have on site, they have a research facility which is staffed by, I think it's Texas A&M researchers and students who are looking into new technologies for lowering that energy cost.
In reference to another base, actually in Fort Irwin, something of very similar capacity build-up for a desalination plant and a wastewater treatment plant. The wastewater treatment plant increased the cost of the water itself by 100%, and then on top of that, the desalination plant is expected to increase the water another 400% from the current price. So it's going to jump up to be maybe, instead of being $1.68 right now, it's expected to go up to about $16 per 1,000 gallons.
And the second question, you mentioned regional planning, and in a lot of your models, you took into account climate change and modeling for climate change. When you're working with the regional planning, particularly in Texas, are you seeing them taking into account in some of their modeling climate change, or are they just expecting status quo ad infinitum?
Well, it will vary. There are, I forget the exact count, but there are many regional planning bodies. So each one will do a different plan, and it might be a different format, different contractor doing it. So I can't speak to all of them. With Bliss, there were some studies actually done by sort of the local expert who worked at El Paso Water Utilities at the time. And he had done a survey of all the climate models and done multiple runs. And he contended that, so they were looking at it, but he contended that even though there is a lot of variability, that the water utility, which is one of the major ones for that region, the major one, is incorporating it into their planning to the extent that they plan for the past, their planning accommodates the past 300 to 500 years of water behavior and precipitation based on tree ring data they'd studied, and the variability he asserted is expected to be within that range, so they will be okay. But so looking at that, he has a lot of hard science behind it, and he is an expert in that area for that aquifer. But at the same time, their projections go up to between 2060 and 2070, saying under that scenario, yes, we'll have enough water. But we have to ask the question, okay, once we hit 2060 then, okay, are you out of water, even though you're okay until then? So they do take it into account, but there's always argument. Fort Bliss, somewhat, not the whole base, but I think one commentator wanted a no climate change scenario put in. So we did it, and it's something that you can do with the model, which is a strength, is to make new scenarios. But at the same time, most of them do incorporate climate change because it seems to be, well, to me personally, a scientific fact. Well, our bias should probably be clear if it's a bias. But not everybody agrees, so I think they talk about it in the different plans in different ways. It's a political battle.
The demand side of your model, it looked like the demand was pretty much fixed based on the number of people at the base. Is that true in your model, or can you, because I'm wondering if you could account for, say like in a drought year, maybe you enforce regulations like, everyone takes a 2-minute shower, or if they're using swamp cooling for air conditioning, and you raise the thermostat up to 80 degrees. Is there some flexibility in the demand?
Are you speaking directly to the installation itself?
In your model that you've put together, do they care about that, or do they just say, here, number of people, average, this is fixed?
It depends on how. Well, you've got the executive order that's requiring the base to enforce water conservation measures up to 2020. How they do that, there's several different tech reports and recommendations on different fixtures and high efficiency toilets and everything like that. So more than likely they're going to implement limitations that way before they start requiring only 2-minute showers. That's also kind of a sticky issue because there's a quality of life that soldiers expect. Everyone kind of expects to have on the domestic side of the base. So that hasn't gotten there yet. I think the base will probably follow whatever public legislation is being enforced at the time too. For example, I'll bring in like California. They just passed a new water legislation. Well, the bases are going to have to follow the same lead too.
I think that our demand models are just predicting, as you pointed out, average demand. But what I'm doing with some of my installations, there's a general formula that you can predict, for example, peak demand off of average demand. So although the model is predicting average demand, I'm then using that average demand to talk about peak demand and requirements for a new water treatment plant in the area. Likewise, we've sort of embraced a scenario approach to this, and although Fort Bliss was a installation we studied in our pilot study, and the ones we're doing now, we're doing 10 additional installations now. But I'm finding it easier to incorporate the possibility of a drought and implications that might have for demand in different scenarios, so that the model's predicting average, and then when I have a scenario, I say, okay, well, what if this new regulation comes in that affects how people use water? So we are incorporating it into the scenarios, not into the model's predicting average demand, but you can incorporate that into the scenarios.
I can add something to that. The model is built so that if you was for say, in 2020 consumption for residential units might be a little bit lower, you can actually put that value in that cell, and so it'll predict.
And I'll make one comment. I don't know if you noticed on one of those spreadsheets, I don't know if it was one of the sexy ones or not. And on the bottom left, there was a place to put water rate, and some people around here may be sensitive to water costs. We have another increase coming. The Army is sensitive to increased costs of utilities as well. It's a big driver for conservation. Historically, for energy, we believe it will be for water, and that's why we incorporated costs. We are seeing rates increase right now in the Army, and we primarily purchase our water rather than self-supply it. What a commander of a base says goes. And I don't know about too many showers, but there have been irrigation restrictions at Fort Bragg, one of our study sites, in times of drought. I'm sure that
Also with Carson, yep.
But for, at least I knew some people at Air Force Base in Albuquerque, but it seemed like they don't, like individual houses don't pay their water bill. Is that right?
That's
So
correct.
They're not
Yeah.
metered.
That's one of the
Yeah.
challenges of using RC installations because they're not metered and it's not accurate.
I think that trend might begin to change a little
Yeah.
bit too. The Army's trying to meter water use a lot more. They're trying to phase that in and to pass the cost on. I know at one of my bases they're in the process of figuring out how to pass that cost on to the housing now.
well, because the Army said going back 15 years or so, we will never charge our tenants for energy, and now they charge their tenants for energy, according to an average energy use for a typical home.
Right. I was going to say for Carson, they don't meter, but they have a base rate. Well, they meter, but they don't pass the bill along. So they have a base rate, and then if one goes over, they have to pay the extra, and if one goes under, then they have an incentive for doing that too.
I had a question about Fort Irwin that you brought up. It's in such a drought-ridden place. Does the Army ever consider them moving the base? I mean, since the water costs are going up so high, and it didn't seem like the best place to have it.
The history behind Fort Irwin kind of answers that to an extent. The base was settled in the late 1800s as an outpost, and then it was populated again for World War II. And then shortly after World War II, the use was limited, so they actually abandoned the fort between like 1964 up to 1980. And then they reactivated the fort. That's the big question right now, really, because there's one basin that they expect that through our modeling and through their own estimations, they've done studies with USGS and their own water company, that by 2040, the basin is not going to have any, you won't be able to recover water from the basin. On top of that, another basin besides is having subsidence issues, which is affecting the operational training that's going on there. It's actually making cracks in the runway that they have there. So although they're putting a lot of money towards infrastructure with the new desalination plant and the water treatment, right now they're kind of shifting the eggs in the basket. They're thinking about, well, we won't pump so much from this basin. We'll go back to this one, but that's the one that we're artificially recharging with our wastewater. So we'll go back to pumping more out of that one. And it's kind of like just changing straws into a glass right now. The possible consideration, I can bring back up the slide. Back. Beneath, so the fort boundaries is a black line. Right here is a Coyote Lake Valley. And it doesn't show, but the population growth in this area is supposed to reach the Coyote Lake Valley basin. And so since it straddles the fort boundaries and it's getting near to actual urban population, the fort, even though it's connected to that basin, it may not be able to pump from that basin, even though that, as of right now, that's their the most likely and most favorable option out of the current 3 basins that they have. So if they do get to the point where they need to find another basin, that's the most likely one. But if you're familiar with the area, this is a very mountainous area. So they essentially have to set up a pump it over a mountain range, and get it to the base. So the energy required beyond what they already are increasing in payment right now, may go up to like 10 times. I mean, it's going to be huge for the cost. So I think that's where the 5-year plan comes in, unfortunately, because you can't really answer, because they've put so much in. There is, let me shorten this, the mission at Fort Irwin essentially trains troops before they go to Afghanistan and Iraq. So it's a very important base to train at. How they do operations there will change significantly. What steps they'll take in the next couple decades, we don't know. They may actually start doing the two-minute showers. But as of right now, they don't meter anything. They don't meter their contractors. They don't meter the troops that come in and take showers out in the middle of the desert. They don't do anything. But they realize it, and they're changing their practices.
They're very motivated.
Yes, very much so. They realize it. I mean, they're not the people there realize it. They're not stupid. Yeah, it's pretty severe there.